Hello student. Last lecture we take the example based on 3 by 3 order determinant. We continue the example for practicing all the pattern. So let us start today's first example. Oh, what do you see on a screen? DET. You may use the determinant word. So 2 minus 3 1, 2 0 minus 1 1 4 5. Same trick we have to apply. We have to skip first row and the first column as a skip. So what is remaining? 0 minus 1 4 5 you should write here, and 2 is the center of element, that's why we write here. Next, our second step is what? We have to skip the second column and first row. So minus 3 is the center of that row and second column. So that's why we should write here minus 3. But always the second term is negative. So we have to take skipping this first row and second column, we derive 2 minus 1 1 5. So I should write here 2 minus 1 1 5. Next one. 1 is available where? Oh, first row and last column. So 1 is the center of element, so we should write here and use DET word also. So we derive what? This and this, skipping 2 0 and 1 4. We know that 0 into anything is 0. 4 into minus 1 minus 4. Middle sign is minus. Minus minus plus 3 is there. 5 into 2 10 and minus minus plus 1. Plus 1 is there. 4 2s are 8 minus 0. So let us try the 2 in bracket 0 plus 4 plus 3 remain as the same. 10 minus of minus 1, 10 plus 1. 1, 8 minus 0 is 8. So we can simplify 4 into 2, 8. 10 plus 1, 11 into 3, 33. And 8 into 1, 8. So we derive the final answer. 8 plus 8 plus 33 is 49. In this example, we better understand we have to use the DET word also to simplify any pattern of the example of order 3 by 3. Let us try one more example. Oh, they given the modulus, that is determinant of A is equal to 6, 2 minus 4, 5, 6 minus 2, 5, 2 minus 3. More negative numbers are there. Let us check what happened. In the last column, second column and first column, we have to must focus. First row, the first element is 6. We should write here 6. So we have to skip first row and first column. What is remaining? 6 minus 2, 2 minus 3. We should write here. Next one is what? Minus 2. Why? Because the middle term always have the negative symbol. That's why we should write here minus 2. So what we have to skip now? First row, second column. So 5 minus 2, 5 minus 3. So I should write here 5 minus 2, 5 minus 3. Oh, which now remaining? Last column and first row. Which minus 4 is the center of element, we have to not forget. Yes, we start from first row and last column, we remain 5, 6, 5, 2. These are the elements. We know that 6 into minus 3 minus 18. Minus 2 into 2 minus 4. But middle sign is minus. Let us try. Minus 2 remain as the same. 5 into minus 3. Oh, it is minus 15. 5 into minus 2 minus 10. But middle sign is minus. So we should compulsory put the bracket with the negative sign is outside. Be particular by this step. Minus 4 remain as the same. So 5 into 2, 10. 5 into 6, minus 30. That's not fair. So let us try. We know that if negative sign is outside the bracket sign will be changed. Minus minus plus. Here also minus minus plus. So 6 remain as the same. Minus 18 plus 4 minus 14. Because 18 is bigger than 4. Next, minus 2 remain as the same. Minus 15 plus 10 minus 5. So minus 5 into 2 plus 10. 10 minus 30 obviously minus 20, but minus minus become plus. 4 into 20, 80. So we derive minus 14 into 6, minus 84, minus 2 into minus 5 plus 10, minus 4 into minus 20 plus 18. We simplify and derive the final answer is exactly 6. In this example, we better understand if negative numbers are there, no problem. Only we have to take the cross multiplication properly, and negative into negative is positive, and outside negative the bracket sign will be changed. Let us try one more example. Evaluate the determinant. I use here, last example I use the word det. In this example, we normally denoted the bar bracket, and this example del is also used, that is the smaller triangle. So let us try the evaluate the following the value of determinant, that is 1, 2, 4, minus 1, 3, 0, 4, 1, 0. Here you look that these elements are 0. What happened then? Let us try. Our procedure is same for all types of 3 by 3 order determinant. Let us try. 1, 2, 4, minus 1, 3, 0, 4, 1, 0. So 1 remain as the same. 1, why we have to take 1? Yes, the first column and first row skip. 1 is the center of the element, that's why we should write here. So what is the remaining? 3, 0, 1, 0. I should write here. Same trick apply for the second column and first row. This is the center element and middle sign is always negative. That's why we write here. So minus 2 is there. So we have to skip first row and second column. What is remaining? Minus 1, 0, 4, 0. You should write here. Last but not least, first row and last column. 4 is the center of element, have the positive symbol. That's why we write plus 4. And what is remaining? This and this skip. What is remaining? Minus 1, 3, 4, 1. You better use the pencil to skip first row, first column, second column, first row, and first row, last column. We derive the same answer. So let us try. 3 into 0 is 1 into 0. Minus 2 remain as the same. Minus 1 into 0. 4 into 0. Plus 4. Minus 1 into 1. 4 into 3. So we try. 3 into 0 is 0. Minus 1 into 0. 0. 0 into anything is 0. Minus 1 into 0. 0. 4 into 0. 0. 0 into minus 2. 4 remains same. Minus 1 into 1. Minus 1. Minus 4 into 3. Minus 12. Minus 12. Minus 1 is minus 13. So we should write 0 into 1. 0. Minus 2 into 0. 0. But 4 into minus 13 is minus 52. In this example, we better understand if instead of bar bracket, you should use the del is also applicable, or modulus of del is also applicable. Whenever you have to suit any notation, we should apply. Let us try one more example. In this example, what you observe? Yes, you observe that 3 2 elements are there, same element, but their position are different. Here 3 2 3, but T 2 2 2 3 3 3. That means the common, that is column 2 have the same element and column 3 have same element. Then what is the answer? Any guess? Let us try our main procedure. First row, first column skip. So what is remaining? 2 3 2 3. I should write here. First row, second column is skip. So what is the remaining? 2 3 3 3 is remaining. Next, first row, last column is remaining. So plus 3. So what is remaining? 2 2 3 2. Let us try. 2 into 3. 2 into 3. Middle is minus and 3 remain as the same. Minus 2. 3 minus 2 derived from 3 minus 2 and 3. Second term, minus 2 remain as the same. 2 3. 3 into 3. Next plus 3. 2 2. 3 into 2. We know that 6 minus 6 minus 2 remain as the same. 6 minus 9, be careful, 3 into 3 is 9. Next 3 remain as the same. 4 minus 6, we know that 6 minus 6 is 0, so 0 into anything is 0, but 6 minus 9 is minus 3. Minus 3 into minus 2 plus 6. 4 minus 6 minus 2, but 3 into minus 2 minus 6, but plus 6 minus 6 give the value is 0. That means from these example we understand if two columns have the same element in each position, then their final answer will be 0 of that determinant. So we understand the best examples which are as in a board pattern example. What is the picture in this? You see, one man is there and there is the gap grammar. Oh, he is the innovator of the Cramer's rule. So we start the Cramer's rule then? Yes. What is the Cramer's rule most probably used? Then we have to study in details. So we have to must focus on the next slide. Cramer's rule for two equation in two variables. So what is meant by two equation and two variables? Here a1, b1 are coefficient of x and y. In second equation, a2 and b2 are the two coefficient of x and y, where x and y are variables and c1 and c2 are the constant of the given two equations. Always Cramer's rule is more applicable when these constant must be non-zero. Then you easily find the value of x and y using Cramer's rule of determinant to evaluate the final answer. Let us try. What is the step number 1? We confirm that given equation system is a1x plus b1y equal to c1, a2x plus b2y is equal to c2. Step number 2, d is equal to, we have to take the coefficient of x and y, a1, a2, b1, b2. We take the cross multiplication, a1 into b2 minus b1 into a2. Next, step number 3, we have to find the dx value. That means instead of the coefficient of x, a1 and a2 in column number 1, we have to put c1 and c2 simultaneously, and b1 and b2 remain as the same. So we derive c1 and c2, b1 and b2. Next, we know that c1 into b2 minus b1 into c2. Step number 4, we have to find the value of y. So we have to find dy. That is suffix of d. What is that? We have to put the, instead of b1 b2 we have to put c1 c2 and a1 a2 remain as the same. So we should write first a1 a2 then c1 c2. Same trick, a1 into c2 minus c1 into a2. Then last and important step, that is we have to put step number 5, x is equal to dx upon d, y is equal to dy upon d. Always remind that these Cramer's rule are more applicable if the coefficient of x and y must be non-zero numbers, at least 1 or minus 1 is available, and d must be non-zero always. Then we have to solve the system of two variables with two equations easily and definitely. Next lecture, we have to discuss the same topic, that is the procedure to find the solution of x and y of the given system using Cramer's rule of determinant. Now we continue the next lecture from the next step, that is the next procedure given below. Let us try, and better we have to revise the 10th example to solve the system